This video is part of the Pure Maths 1 course. It's on the trigonometry topic, and it deals with the cosine rule. The cosine rule is used to solve triangles where either A, two sides and the included angle are known, and this is in this case here, which I'll call 1, where you can see we have this side 10, this side 7, and the angle between them has to be the angle between them is known. Or in the second case here, where we have a triangle where we know all three sides, and in either of those cases we can use the cosine rule to find the other three unknown things. So in the first case, this side opposite the 40 degrees there, and the other two angles can be found. So those two angles and that side. Or in the second case, we can find the other three angles with the cosine rule. Now, it's not possible to use the sine rule in these two cases. If you remember from the last video, the sine rule is this: sine A over A sine equals sine B over B equals sine C over C, which represents three separate equations. Well, if you take if you look at, say, the first triangle here, what you have is angle A, side C there, and side B there. So you have an A, a B, and a C, and if you look at the three equations, you can't take any equation from the three where you've got A, B, and C in it. These two, for instance, just have A and B. These two here have B and C, and then the first and the last have A and C. So you wouldn't be able to, so any equation you chose, say the first one here, sine A over A, where A is unknown, side A is unknown, equals sine B over side B. So, but angle B is unknown. So you'd always have two unknowns. And in the second case, where we know three sides, any equation we pick from the sine rule will contain two angles, and so all the angles are unknown, so we'll have two unknowns. If we take a triangle, any triangle ABC, where the angles are at the vertices A, B, and C, and the sides, as we know, are labelled by the lowercase a, b, and c opposite each of the angles, and I'm going to draw a perpendicular line from B to AC, like that. Okay, I'm going to call the length of the perpendicular H, and we'll call this point there D. AD, I'm going to give the symbol X, so that will be AD, and of course the whole of AC is B, so DC will be B minus X. So now we have two right-angled triangles, ABD and BDC. Now in ABD, so in triangle ABD, it's right-angled, so we can use Pythagoras' theorem, and we can say that the hypotenuse c squared is equal to h squared plus x squared. And in the other triangle, BDC, the hypotenuse a squared is equal to h squared plus b minus x squared. Okay, we have two equations here. I can subtract one from the other. Let's subtract 1 from 2, so 2 minus 1, a squared minus c squared. H squared cancels out, h squared minus h squared, so that equals b minus x squared minus x squared. Okay, so expanding the b minus x squared, we have b squared minus 2bx plus x squared minus x squared. The x squareds cancel. I'm going to add c squared to both sides, and I'll have a squared equals b squared plus c squared minus 2bx. Now going back to the triangle, x, we can see in triangle ABD, we can say the cosine of A, I'll write it over here, which is equal to adjacent over hypotenuse is equal to x over c. So x, if I rearrange, is equal to c cos A. So substituting that into this equation, x equals c cos A, we have a squared equals b squared plus c squared minus 2bc cos A. And that is the cosine rule. Now in any triangle, there's nothing special about drawing a perpendicular line from B to AC. I could have chosen A or C, so I could have drawn a perpendicular line from A to BC, and I would have formulated the cosine rule as b squared equals a squared plus c squared minus 2ac cos b. Similarly, I could have drawn one from C to AB and got c squared equals a squared plus b squared minus 2ab cos c. So essentially the cosine rule, you notice the side that's on the left hand side, A, is the angle in the cosine on the right hand side. So, but it can be any side on the left hand side and any angle on the right hand side. This formula, by the way, is in the formula book. If necessary, we can rearrange this formula to make the angle the subject. So we'd have, if we put 2bc on the other side and the a squared on the right hand side, 2bc cos A, we say, and dividing by 2bc, we have cos A is equal to b squared plus c squared minus a squared over 2bc. The other two equations can be rearranged in the same way for cos B and cos C if necessary. I don't think you should remember this. You should just use this equation, which is the a squared equals b squared plus c squared minus 2bc cos A, which is in the formula book, and rearrange it if you need to. So an example of the use, we have this triangle here, two sides 5 and 7, and the included angle, the angle between the two sides, 63 degrees. And supposing we want to find the side BC, so BC is A. we want to find A. So substituting the values in the formula, A squared equals B squared, that's the side opposite B, 7 squared, plus C squared, the side opposite C is 5, minus 2 times 7B times 5, which is C, cosine of A 63 degrees, which using the calculator equals 42.22, the 2 decimal places, and so taking the square root, A equals 6.498. Again, that will be to 4 significant figures, centimetres. In the case where we have 3 sides known and we want to find one of the angle, here we have this triangle here, sides are 4, 5 and 7. And suppose we want to find the largest angle. Well, the largest angle is opposite the largest side, so BA is the largest side, 7, and the opposite angle is C. So substituting in that equation, now using the standard equation we get in the formula book, just think about the side on the left hand side and is the opposite to the angle on the right hand side. We want the angle C, so the opposite side is 7. So on that side I'll write 7 squared. B and C are the other 2 sides, it doesn't matter which way round. So 4 squared plus 5 squared minus 2BC, the 2 other sides, 4 and 5, 4 times 5, cosine of the angle that we want, cosine of C. So rearranging, 2 times 4 times 5, that's 20, that's 40 cos C equals 4 squared, 16, plus 5 squared, 25, minus 7 squared, 49, which equals minus 8. So cos C equals minus 8 over 40, or minus a fifth, minus 0.2. Now we have a negative value for the cosine. Now what does a negative value mean? Well, if I draw a horizontal line at about minus 0.2, there we see that here is the make that a little bit bigger, and we see that this is the cosine graph between 0 and 360. It crosses the x-axis at 0, obviously, because of 90 is 0. Minus 0.2 is there, below the axis. Here is the first value for which cosine of an angle is equal to minus 0.2, and it's larger than 90. So we have an obtuse angle. From the calculator we find that C equals 101.5 degrees. Now return to Study Smart and practice.